Okay, so we'll start with these problems. So yeah, here we go. We're going to use ordinary division to find the quotient and remainder when the first polynomial is divided by the second polynomial. So just a reminder here of how regular old division works. So if I was doing 32 divided by 5231, I would say, can 32 go into 5? No, it can't. Can 32 go into 52? Yes, it can. How many times does 32 go into 52? One time. And then we do 1 times 32 gives us 32. So we write that down beneath it. And then what do we always do with these numbers? We subtract them. So it's a built-in subtraction problem. So 52 minus 32 is 20. Then once we get that step, we're going to bring down the next digit, the next value, in this case is 3. So now can 32 go into 203? Yes, it can. I would guess it can do it 6 times. Okay, 6 times 32, that's going to be 12. It should be 192. And then again, it's a subtraction problem. So that's 1, 1. And then we bring down this last one. So now 32 can go into 111 3 times. 3 times 32 is 96. And then we subtract. So this becomes a 0. This becomes 11. 11 minus 6 is 5. 10 minus 9 is 1. And so then we're left with a remainder of 15. And so we had a couple different ways we could do that. If we wanted a decimal number, we would add a 0 and keep going and know that everything that comes next is a decimal. Or we could turn this into a fraction. Our remainder, which is 15, is the numerator. And then the number we were dividing by, which is 32, is the denominator. So our answer is 163 and 15 over 32. And that's the way that we want to work these because that's the way we typically do them when we're doing polynomial division. So just a reminder of how that division works. Remember there are built-in subtractions and remember the process for multiplying. So now we're going to do that with this polynomial. So we're going to divide the first polynomial by the second polynomial. So that's going to give me x squared minus 5x plus 7 goes inside the division box. And then on the outside is x minus 2. Okay, so here's the process. We always want to make the first term here eliminate the first term here. So to make them eliminate, we have to make them match. If they look the exact same, then they will eliminate because remember there's a built-in subtraction in division. So here's what we do. I've got an x. I want it to be x squared. So x times what gives me x squared? Well, that would be x times x. Okay, then we have to multiply. X times x is x squared. But then I also have to multiply the x times the negative 2. So x times negative 2 is negative 2x. Okay. Ooh, what happened there? That negative 2x did not get tied down to... Oh, gosh. Give me just a second so I can tie them all together. Whatever. Okay, so now is where there's the built-in subtraction. So what we have to do is we have to subtract these values, which means we're going to change the sign of everything. So I'm subtracting x squared, and then I'm subtracting negative 2x. Well, if you remember, minus a negative is the same thing as plus. So minus Basically what we do is we change the sign of everything. Okay, then we combine them. X squared minus x squared is 0. Negative 5x plus 2x is negative 3x. And then we bring down the next term, which is a positive 7. So now we go through the same process again. I have an x, and I want it to be negative 3x. So x times what is negative 3x? It's going to give us negative 3. Okay, so negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. Now, whenever my term is positive, I normally just ignore that sign. So I don't even put it down because it just makes it easier to go through and change them. So you'll notice me doing that a lot. Now, when I subtract these, I'm going to have to change the sign of everything. So this becomes positive and this becomes negative. Negative 3x plus 3x is 0. 7 minus 6 is 1. Okay, now I have an x. X times what is 1? Okay, well, that's not so easily answered, right? We're going to get a fraction answer. So whenever this x to the first power has a greater exponent than what's left, so a constant or x to the 0 power, then we know we're finished. That means the 1 is my remainder, so I can write this as 1 over x minus 2. So again, just make sure you're reading what the question is. So right now, it's telling me to give the quotient and remainder. So if that was what it asked for, the answer would be x minus 3 and then plus 1 would be the end. But if they wanted you to simplify it all the way out, then this is how you do that. You put that remainder over the denominator. So just be careful reading the question to know which one they want. Okay, let's do one more today. So what's different here? My trinomial, s to the 4th minus 3s squared plus 6. So this is a weird example. We're going to go ahead and act like this is a normal example. And what I notice is my exponents do not decrease uniformly. We go from a 4th power to a 2nd power to a constant. When we're dividing, we really want every power to be represented. So if I was writing this out, I would write this as s to the 4th plus 0s to the 3rd minus 3s squared plus 0s plus 6. And you'll see right here why I said that this is a weird example. Because right here what I'm dividing by is s squared minus 5. So it just so happens that this one also skips. So we don't have to write out every one of the thing we're dividing by. Just the thing that is being divided into. Make sure we have every power represented. But because they both actually skipped, we wouldn't have to do it this time. But let's just get in the habit of doing that. So now I have an s to the 2nd. I want it to be s to the 4th. So that would be s to the 2nd times s to the 2nd is going to give me s to the 4th. And now we distribute. S to the 2nd times s to the 2nd is s to the 4th. S to the 2nd times negative 5 is negative 5s squared. So you have to make sure you match it up where it goes. So the s squareds are listed right here. So this is going to be minus 5s squared. And we're going to skip over that s to the 3rd.
Where did you get an s to the 3rd from?
Because it was missing. There was no s to the 3rd. There was no s to the 1st. So when we do this division, we want each one to be represented. So I put a 0s to the 3rd and a 0s to the 1st. And that's what I was saying. We didn't actually have to do it on this problem because these skip and this one skips. So it really actually would have worked out without it. But notice, like if this was s squared minus s, then I would have had an s to the 3rd that would have had to have filled in here. And you've got to have that placeholder so you don't get confused with what gets
Yeah,
subtracted
I
where.
was confused because I did it already and it worked out without it, so I was like.
Yeah, it does this time without it. Okay, so then we have to subtract, so that means we change the sign of everything. So s to the fourth minus s to the fourth is 0. 0s to the third, well, it has nothing to combine it with, so we can just leave it alone as well. Negative 3s squared plus 5s squared is 2s squared. And then we bring down everything else that we have, plus 0s plus 6. Now I've got an s squared. I want it to be 2s squared, so I need to multiply by a positive 2. So I'm going to put plus 2. 2 times s squared is 2s squared. Negative 5 times 2 is negative 10. And so again, match that up here with a constant. And now when we subtract, we change the sign of everything. So that becomes negative, that becomes positive. This goes to 0. That has nothing to combine it with, so it's still 0. And then 6 plus 10 is 16. So my answer here would be s squared plus 2 with a remainder of 16. Or we could write that as 16 over s squared minus 5 if it asks us to do that.